ID, the Future, a podcast about evolution and intelligent design.
Welcome to ID the Future. I'm Andrew McDiarmid, and today I have the privilege of welcoming back Dr. Gunter Bechly. He's going to discuss another of his popular Fossil Friday articles published at evolutionnews.org. This time we're going to chat about some major problems with arachnid phylogeny, that's right, spiders, and the implications for the common descent hypothesis. Now, in case you're not familiar with his work, Dr. Bechly is a German paleoentomologist who specializes in the fossil history and systematics of insects, the most diverse group of animals. He served as curator for amber and fossil insects in the Department of Paleontology at the State Museum of Natural History in Stuttgart, Germany. He is also a senior fellow with Discovery Institute's Center for Science and Culture. We're delighted to have him. And Dr. Bechly earned his PhD in geosciences from Eberhard Karls University in Tübingen, Germany. Gunter, so great to have you.
Thanks for inviting me.
Absolutely. Well, for listeners who are not aware, you've been publishing a fascinating weekly article series at evolutionnews.org since about the summer of 2022. It's called Fossil Friday. Each week you illuminate the story of a different fossil, explaining the part it plays in the larger story of the fossil record, while questioning some of the evolutionary assumptions that might be connected to it. Each piece is accompanied by at least one striking image of the fossil being discussed, and sometimes those images come from your own collection of photos. Now today we're unpacking one of your recent articles titled The Mess of Arachnid Phylogeny and Why I've Become More Skeptical of Common Descent. That's a catchy title, and there's a couple things going on there that we're going to want to unpack today. This piece is a whopper as well, with 160 references complete with links to sources. I went through and counted them. What a wonderfully detailed review of this particular area. Wow. And you were mentioning that, you don't cite anything unless you read the paper, which I think is great practice.
That's right.
Yeah. So which fossil do you highlight in this article?
Now, in that article, I highlighted an animal called Chimera arachne yingai. And this animal was described by Chinese scientists in 2018. It is a spider-like animal from Burmese amber. So that's amber from Myanmar in Eastern Asia. And this amber has been dated radiometrically to a mid-Cretaceous age of about 99 million years. So this animal is tiny. It's just a few millimeters in size, and it looks like a small tarantula. It has spinnerets, and most interestingly, it has a long tail filament, so a long kind of thread at the end of his body. And this latter structure is totally unknown from any other fossil or living spiders, but it is known from some other arachnid orders, such as whip scorpions, for example. So this was particularly interesting because such an animal was allegedly predicted by evolutionists. And I believe this to be true. And actually, I considered this to be good evidence for common descent, because usually such specific successful predictions are a hallmark of good scientific theories. So when I wrote this article and I more carefully researched this issue, I discovered to my surprise that no such explicit prediction actually existed in the first place. It was basically made up after the fact in a press release. And also, if you look at the distribution of this character, of this tail thread, this flagellum in living and in fossil arachnids, it is so incongruent. It is, for example, absent in all of the oldest spider fossil. It is absent in the fossil relatives of spiders and of whip scorpions, respectively. So that even an implicit prediction, which would be based on the character distribution and the principle of parsimony, even such an implicit prediction would not have been warranted. So after the research, I had to conclude that this alleged successful prediction evaporated and does not stand to scrutiny. And it's quite similar to another alleged successful prediction, which was cherished by the Darwinist author Jerry Coyne in his book, Why Evolution is True. And he talked about the prediction of this fisherpod Tiktaalik, famous transitional fossil. And there also later evidence showed that this successful prediction was just a lucky accident based on false assumptions. So ultimately, the rarity and the dubious status of such predictions is one point that made me a bit more skeptical of the claim that common descent is an indisputable established fact.
Yeah, yeah. So this little spider, you're saying, has different features that are not found elsewhere, and yet they claim to have made predictions about these features already.
Yes.
Okay. Well, we'll dig into that a little bit. Now, you were telling me that you prefer your spiders in amber, prefer them dead rather than alive. And I'm right there with you, and I'm sure a lot of our listeners are. In fact, I just had to deal with one with my daughters a few days ago, uncomfortably close to her bed, mind you. But anyway, tell us, remind us what constitutes an arachnid, and give us some examples.
Yeah, sure. So arachnids, it's not just spiders. So Arachnida is one of the major subgroups, and these subgroups are called classes of the phylum Arthropoda. And arthropods, as you probably know, include different animals like crustaceans, myriapods, that would be millipedes and centipedes. It includes insects or hexapods, and of course, arachnids, and then also some extinct groups such as trilobites, for example. So arachnids include all the spider-like arthropods, and this would be orders like scorpions, mites, harvestmen, sun or camel spiders, whip scorpions, whip spiders, and then, of course, true spiders with all those orb-weaving spiders that are well known. And even though many people don't like them, but at least they appreciate this miraculous, wonderful construction of the spider webs. So arachnids are terrestrial arthropods. They are almost exclusively predatory, and they have a bipartite body. So that's different to insects, which have a tripartite body made of three major parts. In arachnids, it's a two-parted body, and it has 4 pairs of walking legs, so 8 legs, typical for spiders, and also the other arachnids. While insects, for example, have 3 pairs of legs, have 6 legs, and centipedes and crustaceans have many more. So that basically characterizes the group of arachnids.
Okay. Now, you write in your article, every reconstruction of past events is a hypothetical inference to the best explanation based on circumstantial evidence and a lot of theoretical guesswork based on shaky assumptions. Now, when it comes to organizing and grouping living things, a lot depends on the biases and preconceived ideas of the person doing the grouping. So if a scientist already has a commitment to both methodological naturalism and Darwinian evolution, the organizing becomes just an elaborate way of demonstrating what might already be expected in an evolutionary framework. But, on the other hand, if a scientist is willing to look at biology as the product of design, the grouping and organizing might look very different. Now, that said, how is arachnid phylogeny typically organized, and where do the problems lie?
Yeah, so the problem is in the little word typical, because as I show in the article, there simply is no typical arachnid phylogeny in terms of kind of scientific mainstream consensus, but there is a genuine mass of conflicting trees that have been published, even if you just look at the past 10 years. So you don't have to, let's say, take decades of work and maybe obsolete methods or outdated data. But if you just look at the most modern papers of the past 10 years, based on the most modern methods, most modern techniques, most modern data, all those trees that have been published conflict with each other. And so just to give some examples, so some studies recovered horseshoe crabs, which are quite well known, and the extinct sea scorpions that were giant scorpion-like marine spider-related arthropods. they recovered those as marine sister groups, so as closest relatives to the terrestrial arachnids. But other studies have them deeply subordinated within Arachnida. And this means that in one case, the terrestrial lifestyle of arachnids would be one event and they would be one group. And in the other case, this would show, because you have these marine groups nested within the terrestrial arachnids, that terrestrialization, the adaptation to land, would be independent and would not be a single event. And that would imply that the complex air breathing organs would be convergences, would be independently gained, and that structures like compound eyes would be multiple times independently lost. So a lot of implausible consequences of these conflicts in the trees. And also, if you look at the interordinal relationships of the different groups of arachnids, so groups like scorpions and whip scorpions and spiders, there's not a single topology of these about a dozen orders of arachnids that is recovered in all these published trees of the past 10 years. So the only interordinal grouping that is occurring in all but one tree, so it's also not in all trees, but in most of the trees, is a clade of whip scorpions, whip spiders, and spiders. But again, towards each other with very different internal topology, with different closest relative to spiders, which again has great implications for the evolutionary scenarios. So there's a lot of conflict in these trees. And it's not just that you have conflict between, let's say, anatomical data and molecular DNA data, which produce different trees, but it's also not that just different methods produce different trees. Let's say that cladistics produces other trees than Bayesian methods. But it's even if you take one method, let's say cladistic studies, and just one type of data, let's say traditional comparative morphology, it still produces totally different conflicting trees. And there has been a paper that I also quote in my article by Sharma et al. From 2014. And they have explicitly shown that if you look at these published modern trees and you calculate something that is called a consensus tree, which is just a kind of common denominator between those trees, that the result is an unresolved polytomy where all those different groups of arachnids are just coming out of one branch. There's no internal structure, no dichotomic structure. It's just looking like a bush or a lawn. And this shows a kind of literal collapse of phylogenetics as a kind of scientific endeavor, which is quite surprising and also quite revealing.
Yeah. So when it comes to arachnid phylogeny, what's typical is that it's atypical, right? Or not typical. Okay. Well, a lot of your work shows that what the fossil record actually reveals is very different than a natural Darwinian process might produce. In this article, you write about a mismatch of molecular clock datings and the actual fossil record. Why is that a problem?
Yes, so this is a very frequent mismatch, by the way. It's not just in arachnids, it's basically in all groups. Wherever you look, you find this mismatch between datings of certain events by molecular clock studies and the dating you arrive at when you look at the fossil record. So in the case of arachnids, molecular clock studies have suggested that the terrestrialization of arachnids happened about the transition from the Cambrian to the Ordovician period. That would be about 485 million years ago. But if you look at the fossil record, the earliest fossil record of terrestrial arachnids is from the Silurian, and that is not just a little bit later, it's about 60 million years later. And as I said, such mismatches are very common. They rather represent the rule than an exception in modern paleobiology and in modern evolutionary biology. So as you ask, why is this a problem? The problem is that this is, of course, unexpected under Darwinism. You always have to ask yourself, what does a theory predict to find, and then compare what do you really find with your empirical data, and Darwinism would predict that different lines of evidence, such as molecular clock studies and the fossil record, should converge to one true history of life. And therefore, this large amount of conflicting data has to be explained and has to be recognized as valid and as good evidence against common descent or against the Darwinian picture, because you cannot just cherry pick the cases where it fits and say, oh, this is supporting Darwinism, but all the cases where it doesn't fit and where you have these conflicting data, not count those as valid conflicting evidence. So that is the reason why this mismatch is a big problem for Darwinism.
Yeah. And the problems continue with the origin of spider silk and spider spinnerets. Why are these features fatal problems for neo-Darwinian theory?
Yes, first, of course, it's something that everybody, I think, intuitively recognizes, is that spider silk, and you may have often heard that spider silk compared to the thickness of the thread is more strength, has more strength than the best artificial materials made from plastics or even from iron or steel. And also the construction of these spinnerets, which are so sophisticated that they can be used to produce these wonderful spider webs, that these structures are marvels of engineering. And they are not just marvels of engineering, they require something new, and they require new proteins for the spider silk. They require new tissues for the glands that produce the spider silk. They require new complex organs with all that is related to that, with the musculature and the nerves that are required to adjust those spinnerets to produce the spider webs and so on. So this requires a significant engineering and re-engineering, and this certainly also required numerous coordinated mutation. It's certainly not possible to achieve this with just a few random point mutation, and this leads to this famous waiting time problem on which I'm working since several years, and which basically is the problem how to accommodate the required genetic changes in the geologically available, relatively short window of time. And we have already talked about this problem in previous episodes of this podcast and also in previous articles at Evolution News. But there's also a more specific problem concerning the spider silk and the spinnerets. And that is, if you look at an extinct group of animals that are considered as close relatives of spiders or as a stem group of spiders, it's called the Arachnidae. They're a Paleozoic group of arachnids. And there are some well-preserved specimens which show, even on a microscopical level, that they did possess these silk glands. But these silk glands were not arranged on spinnerets. They were just placed on the hind body without these multi-segmented and very mobile spinnerets. So, which of course might question the homology of these glands. But even if they are homologous, there's a much more severe problem, and that is if we look at the spider spinnerets, and they have been studied very carefully based on comparative morphology, but there are also genetic data which show that they are considered as homologous and derived from leg-like appendages that are homologous, for example, to the gill branches of the legs in horseshoe crabs. But these Arachnids, which are considered as the closest fossil relatives of spiders, or the stem group of spiders from which spiders evolved, they do not have any leg-like appendages on the hind body, the so-called opistosoma, at that place where the spinnerets would be. So the assumed stem spiders totally lack any of the precursor organs from which spinnerets of spiders are thought to have evolved. And this, of course, does not make sense. And it is, again, definitely not what Darwinism would expect to find. So that is one major problem. And finally, there is also, if we look at this Burmese fossil, Chimera arachnid, there's a problem with its spinnerets. And this is certainly a real spider, apart from this strange character of this tail filament. And the problem with this animal, with the spinnerets, is even recognized by its describers. In my article, I quoted the Chinese paleoentomologist Bo Wang, who wrote in 2018 and wrote a very revealing statement. And I quote verbally, he said, based on the anatomy of Mesoteles are the primitive spiders. There are also still living representatives of them. We would have expected a spider ancestor to have 4 pairs of spinnerets, all positioned in the middle of the underside of the abdomen. Chimera arachnid only has 2 pairs of well-developed spinnerets towards the back of the abdomen, with another pair apparently in the process of formation. So this is again another failed prediction of Darwinism, where the evidence shows it is totally different from what we would have expected based on the Darwinian scenario, how the structure should have developed from its ancestors. And biology is rampant with such failed predictions. And these, of course, have to be weighed against some few isolated success stories. So in my article, I quote this famous saying, even a blind squirrel can find a nut once in a while. And so it's not sufficient to point to those few cases of success stories if you don't count all the many cases of failed predictions. So these predictions can hardly count as strong evidence for common descent.
Right. Yeah, I agree. Well, your article lays out in incredible detail 2 major problems with the predictions that scientists have made thus far about arachnid phylogeny. It seems to boil down to a problem of time and a problem of simplicity, which you call parsimony. Is that accurate then?
Yeah, that's true. And in other words, it's a problem of conflicting evidence between molecular clock and the fossil record, and between different phylogenetic trees based on different data. So there is conflict everywhere. And as I already said, that's unexpected. Different lines of evidence should converge on one true tree of life if common descent is true, but they don't. And this strongly suggests that even if common descent should still be true, that evolutionary biologists are missing something essential to explain the origin of biological diversity and complexity. And they cannot just discuss all the conflicting evidence away with some rescue devices. This has to be explained, and it has to be explained why the theory predicts one thing and what we actually find in the data is something very different.
Yeah. Well, you write that nothing is forbidden in evolutionary fantasy land as long as the fundamental paradigm of common descent with unguided modification isn't questioned. What would happen to arachnid phylogeny if a design perspective were applied to it?
That's an interesting question, actually. So I think if as soon as you allow for common design rather than only common descent as explanation for similarities. So it's not an either or. You can have, let's say, in some cases, common descent can be a valid explanation. But if you restrict your explanation only to common descent and you do not allow for common design, then of course you limit your possibilities. Let's say if you allow for common design as additional option in your realm of possible explanation, then you can accept a common origin for similarities, even if those similarities do not fit into a nested hierarchy and are not well explained by common descent and are maybe better explained by common design. So you are in a way more free to follow the evidence wherever it leads. And to put it more generally, I would make a kind of heretical claim, and that is that phylogenetics is maybe much, or not maybe, it is much overrated. It's mostly a failed and a superfluous discipline. Of course, it has value for the phylogeneticists who publish those studies and publish those trees and make their calculation and reconstructed phylogenies and so on. But if you look, is there any practical value for applied science, or is it heuristically useful? It's basically not. So most of biology and of paleontology, of paleobiology, could perfectly do without phylogenetics. So it's not like it's fundamental or essential to do science in these fields. So I would also suggest that if we take a design approach, that this would be practically and heuristically useful. And actually, it is used in actual science all the time. It's just, it is labeled as, it's only a useful metaphor. We don't mean it literally. But if you look at the language that scientists use in fields, for example, in systems biology or in biomimetics, the articles are full of design language, which shows that it is indispensable. And there you can make, as in mathematics, in the theory in the philosophy of mathematics, there is something that is called the indispensability argument, that there has to be something real in mathematics, which is not made up by us, but which is corresponding to something true in nature, because you have this indispensability of mathematics to do physics. And here you could also make an indispensability argument. It could say this design language is so indispensable to even study these phenomena and to talk about these phenomena that this points towards the reality of this design approach, and that it's not just apparent design, but that it's real design.
Yeah. That's very interesting and intriguing, what you're saying about phylogenetics in general. Not dismissing it, of course, but certainly putting it in its place and suggesting that it might be overused, overrated. And I can see that. I can see how scientists might try to force data to make sense within an evolutionary framework, when really there's really no need to do that, you know.
Right.
And you point out not only that there are many conflicting phylogenetic trees, but that the possibility of there being one consensus tree is implausible. You talk about the evidence pointing to a collapse of phylogenetic theory and its predictions from common descent with modifications. What would biologists need to do then to fix this mess? I mean, they're not all going to jump on a design hypothesis, but what are some ways to fix this?
That is again an interesting question, and it's a very important point, and basically it refers to what I would consider the most important take-home message of my article. And that is, as I said, if you look at these various phylogenetic trees, and that's not just in arachnids, it's basically in all groups. I have made a similar point in a recent Fossil Friday article on insectivorous mammals, that if you just look at the published phylogenetic trees of the most modern research on a particular group, and you calculate this kind of consensus tree as a common denominator, then those trees are so conflicting that they tend to collapse to an unresolved bush, which is called a polytomy in phylogenetics. So, which means that all branches originate in one point and you don't have a kind of dichotomous structure in this tree. And this is, of course, mainly because you have these conflicting data, conflicting topologies based on the conflicts in the different data sets, which, as I said, contradicts the Darwinian predictions and in a way confirms this kind of lawn view of Darwin critics. There is, of course, some structure that would survive this procedure of calculating a consensus tree. So it's not like if you would take, let's say, the whole tree of life and you would look at all the studies, that there would no longer be mammals or birds or dogs and cats. There is some structure that would survive that is basically uncontroversial and that is occurring in all the trees. And that's basically the categories, the groups of the pre-Darwinian Linnaean classification. So the phyla, the classes, the orders, the families, they would be confirmed. But all the interordinal and interfamily groupings that are postulated by Darwinism, and by the assumption of common descent with modification, they would evaporate and would disappear and collapse into these polytomies. So you would have the phyla, classes, orders, and families, but no connection points between them. And I first suggested this argument in these 2 Fossil Friday articles on arachnids and insectivore mammals, but I will further elaborate on this in the near future because I think it's an interesting argument, relatively a new argument to basically illustrate this conflict in the data and these conflicting trees in phylogenetics, which shows that modern phylogenetics in a way backfired against common descent. It's not only not supporting common descent, but it actually weakening one of the main arguments in favor of common descent, which was this argument from the nested hierarchy and that all the characters agree, or as Richard Dawkins said, that all the trees converge and there is no conflict and there's one true tree of life. That is basically refuted by modern phylogenetics.
Okay. So is it fair to say that as you're probing phylogenetics in general and coming up with questions about that is what's driving your recent skepticism of universal common descent? Are they intrinsically linked?
They are, of course, linked. So the 2 main points that made me more skeptical, but I will in a moment qualify this statement. Which made me more skeptical is once that in a lot of cases where I looked into these alleged successful predictions, they turned out not to be true, and either the predictions were never made, or they were just lucky coincidences, or they were false. So that was something that made me think, because that was one of the strong points where I thought, well, common descent, if it makes very particular, very specific predictions, and they turn out to be later confirmed by discovered empirical evidence from the fossil record, for example, that would be a strong point in favor of common descent. So that was one. And the other was this rampant conflict in the data and conflict between molecular clocks and fossil record, conflict between the order of appearance of groups in the fossil record and the order of branching in the reconstructed trees, and these lot of conflicts between the different reconstructions of phylogenetic trees, which do not really fit with this assumption that there should be one true tree of life. So this made me more skeptical, but I wouldn't say that I've necessarily become dismissive or totally skeptical of common descent per se. I still think that for the moment being, that the total evidence, the cumulative evidence, is maybe best explained or most elegantly explained by common descent. But what is certainly true is that some of the strongest arguments that have been cited and that are commonly listed as proofs of common descent or strongest evidence for common descent, that they are either invalid or much weaker than it is commonly presented by popularizers like Richard Dawkins.
Okay. All right. Some interesting points there. Have there been any attempts, as we wrap up, I just wanted to revisit this one more time. Have there been any attempts thus far by ID scientists to group organisms through a design framework? In other words, alternatives to different phylogenetic trees, or a different way of going about it?
Not really. And actually, I think that's not the way we should go. So generally, I think the best, and that has nothing to do with intelligent design. I think that that's also applying to mainstream biology. I think we should more or less return to a kind of Linnaean classification based on grouping organisms according to overall similarity, which has been called in the 1970s phonetics, where groups are defined by their unique combination of diagnostic characters and their clustering according to overall similarity, without any recourse to evolutionary assumptions. And this is even important from an evolutionary point of view to avoid circular reasoning, that you put, let's say, evolutionary assumption into your classification, and then you interpret your hierarchical classification in terms of a tree of life and in terms of evolution. This was actually recognized by different movements of modern biosystematics in the 20th century. One were the phyneticists in the 1970s, and the others were a group called the pattern cladists or the transformed cladists in the 1980s. They recognized this risk of circular reasoning, and they called for a theory-free classification. So, and that's what I would support too. I think classification should be based on patterns of similarity. This has to come first. And then all interpretations should come later and should be based on these primary data. So evolutionists can, of course, interpret their the similarity-based classification in terms of common descent with modification. And design theorists can alternatively interpret these classifications based on similarity in terms of common design. But the classifications themselves should be theory-free to be available as primary data. So that said, I think there would be a potentially fruitful design approach based on a hypothesis or a methodology that was introduced by our friend and colleague Winston Hewitt, which is called the dependency graph hypothesis. And this is based on analogies to object-oriented programming. And we already know that many software metaphors have corresponding phenomena in genetics, such as error correction and data compression and data redundancy. So this approach could be something that could interpret biological classification in a very different way, where you can explain similarities from a design perspective. But as I said, I think the classification itself should be free from theory. So I do not advocate a design-based classification instead of an evolution-based cladistic classification, but a theory-free classification based on maximum overall similarity, basically a return to Linnaeus.
Yeah, I like the sound of that. It sounds like there's a lot of sense in that approach. Well, Gunter, it's always a pleasure to dive into these topics with you to get more clarity and to really go deep into what you're researching and presenting with these articles. Your Fossil Friday series is a great resource, and we'll have you on again to discuss more articles soon. Thanks for joining us.
It was my pleasure.
Well, you can read Dr. Bechly's Fossil Friday series weekly at evolutionnews.org. That's at evolutionnews.org. Until next time, I'm Andrew McDiarmid for ID the Future. Thanks for listening.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.